Hello, I'm here to introduce our temporal dynamic detection transformer. Browsing entire videos can be time-consuming. People want to jump straight to the moment that matches a text query. Given an untrimmed video, moment retrieval is to retrieve a video segment that semantically corresponds to a sentence. In this paper, we find the spurious correlations between the text queries and the target movement. The model makes predictions by overly associating queries with background frames rather than distinguishing target movements. Even when we mask out true movement, some models still predict nearly the same movement. For example, baselines predict the spurious ground truth even if the target movements are masked. In contrast, TD data predicts the segment near the mask with lower confidence. To address the spurious issues, we propose a dynamic learning method with two novel strategies to mitigate spurious correlation. Spurious correlations often stem from linking the movement's context to the text query. We address the issue by synthesizing new samples for the target movements with more dynamic contextual variations. We synthesize new training samples by pairing similar videos and mixing tokens, while always preserving the ground truth movement. Firstly, for each video, we pair the most similar videos in a batch. After that, we sample tokens with selection probability alpha, concatenating them while keeping the ground truth intact. This synthesizer enforces model to attend to a target movement corresponding to the text query and distinguish it from dynamic context. The attention of detection transformer-like architecture associates text query with visual representations. Unfortunately, this tends to emphasize background frames, causing the spurious correlation. To this end, we introduced a dynamic enhancement module to encourage our model to align text queries with temporal dynamic representations. First, we calculate temporal difference tokens by element-wise differences between video tokens to capture dynamics. After obtaining dynamic tokens, we use cross-attention for both text vision and text dynamic representations with the same text query and fuse them with a weighted sum. This encourages the model to align text queries with both video and temporal dynamic representations. We first evaluate our method in standard evaluation. We achieve sorter performance in two popular datasets. To measure spurious behavior, we mask out the true clips while keeping duration unchanged and report spurious R81 and spurious MAP where lower is better. Across three backbones, plugging in our modules reduce spurious metrics while improving standard MAP. We choose the ablation study here. VSDC stands for the video synthesizer for dynamic context, and the TDEM stands for the temporal dynamics enhancement. In addition, we plug our methods in three data-based and one convolution-based methods to show its generalizability. Here, the video shows a man speaking, and the query specifies a man wearing a cap backwards talking while other videos appear in the bottom left corner. Baselines tend to predict long spans that ignore the distinctive other video appear Q, while our TD data focuses on the correct segment. To sum up, our key contributions are: first, we identify and quantify spurious correlations in movement retrieval. Second, we propose dynamic learning via video synthesizer for dynamic context and temporal dynamics enhancement to mitigate these correlations. Finally, we achieve sorter across QV highlights and shares STA and provide clear interpretability through spurious metrics and qualitative cases. Thank you for your listening.